Hello everyone. Today we are going to learn about the TCA cycle or the Krebs cycle, also known as the citric acid cycle. You can see here the intermediates of the TCA cycle. Shout out to the microbes notes from where I collected this picture. So it is sometimes hard to remember all these names of these intermediates of Krebs cycle. So you can remember it by this mnemonic, that is, officer, can I kiss some strangers for money? Here the O stands for the oxaloacetate, C for citrate, I for isocitrate, K for alpha ketoglutarate, S for succinyl-CoA, another S for succinate, F for fumarate, and M for malate. Although this mnemonic is a bit odd, but it still serves its purpose. That is, it will help us remember the intermediates of that Krebs cycle. So in the first step, the acetyl-CoA that we got from the pyruvate and the pyruvate we got from the glycolysis, this acetyl-CoA enters this TCA cycle, and with oxaloacetate it forms citrate. The enzyme here is the citrate synthase. Whenever you see this word synthase, you will remember that it will synthesize the first word that is mentioned in its name, that is citrate here. So citrate synthase means it will synthesize citrate. From this citrate, aconitase enzyme will produce isocitrate. Here the carbon number will remain the same, but there will be an isomerization, that is the hydroxyl from the fourth carbon will be transferred to the third carbon. Why does this isomerization reaction occurs? Because in the next step we will remove a carbon dioxide, not we, the cell will remove the carbon dioxide from the isocitrate to produce alpha ketoglutarate, and for this reaction it is fundamental that it becomes the isocitrate. So in the next step, as I have said earlier, the isocitrate is converted to alpha ketoglutarate through isocitrate dehydrogenase. So remember, whenever you see this dehydrogenase, that means it will go through an oxidative reaction, and this carbon dioxide removal is decarboxylation. So this process is oxidative decarboxylation. Oxidative means it will take away hydrogen atom. Like in this case, the NADA is taking away hydrogen from the isocitrate to produce NADH. On the other hand, it also is taking away carbon dioxide from the isocitrate to produce alpha ketoglutarate. So the carbon number from the isocitrate is reduced by number 1. Then this alpha ketoglutarate is converted to succinyl-CoA. This is here another step that goes through the oxidative decarboxylation. That is, a carbon dioxide is removed and hydrogen atom is also removed by NADH. As I said earlier, whenever you see this dehydrogenase enzyme, that means it is taking away hydrogen atom from the substrate. Here, the hydrogen atom is taken up by the NAD to produce NADH from the alpha ketoglutarate and to produce succinyl-CoA. Then succinyl-CoA synthetase enzyme will produce succinate. Here you can see the word synthetase, that it will come to your mind that it should produce succinyl-CoA. Why is it producing succinyl-CoA why is it producing succinate from succinyl-CoA? It should be the other way around, right? Actually, when the enzyme was discovered, it was the other way around. That's why it is said succinyl-CoA synthetase. It's the enzyme's synthetic function is to produce succinyl-CoA from succinate with the help of ATP or GTP. But for this Krebs cycle, this function of this enzyme is reversed. That is, it will produce succinate from succinyl-CoA, and instead of using up ATP or GTP, it will produce a GTP. As you can see here, that is, GDP is turned into GTP by succinyl-CoA synthetase. Then we will see another dehydrogenase enzyme. And what did I say about dehydrogenase? I said that whenever you see dehydrogenase enzyme, that means the hydrogen atom is being removed from the substrate to produce a high energy substance like the FADH2 here. The FAD is taking up hydrogen and producing FADH2, and the succinate is converted to fumarate. In the next step, by the activity of fumarase enzyme, the fumarate is converted to malate with an addition of hydrogen H2O, that is water. And in the last step, we can see that another dehydrogenase enzyme that will convert the malate to oxaloacetate. Here also another NAD is converted to NADH, as we said earlier, by the dehydrogenase enzyme. So, what is the final products of this Krebs cycle? The products are one ATP, because we have seen this GTP is produced in the fifth step of this cycle, and a GTP is an equivalent of ATP, and 3 NADH, as we have seen in the third, fourth, and eighth step, that 3 NADH is produced, and FADH2 that is produced in the sixth step of the reaction, and 2 carbon dioxide that was produced in the third and fourth step by oxidative decarboxylation. So this is the Krebs cycle in short. Hope this helped you. Thanks for watching the video.